Hello, ladies and gentlemen. Very warm welcome to today's session on state diagram. Myself, I am Chandra. I'm going to explain you how state diagrams are created and when we have to use the state diagrams, what are the different parts of the state diagram. State diagram is a type of diagram that is used to describe the behavior of the system. Mainly, in which state does it exist? State diagrams require finite number of states. Means it cannot have unlimited different forms of state, and then it cannot be having unlimited transitions from one state to another state. So it should have a limited state. Every state diagram has an initial state and the final state through which it transits. So this could be easily understood with any of the chemical processes. For example, it could be an initial state which is water, right? So if you take an example as a water, when the water gets heated up, it gets into vapor state where it becomes part of the air and the particles of the water gets evaporated, right? It will become vapor state. Similarly, if you condense that, if you bring that vapor into much below degrees than below the 0 degree, right, then it will become condensed and it becomes solid and it converts it into ice, right? So this is another transition of state. And the final state is in the ice block, right? So initially it was in the water state and finally it got transited into ice state. So this is how we represent the formation of one chemical out of another, or one form to another form is represented using state diagram. State diagrams are also called as state chart, state machine, state transition diagrams, and so on. Three important elements to consider in the state diagram is the state itself, in which currently it is there, or an event that is triggering a transit from one state to another, and actually transition, so which is happening through the one state to another state. Now with an example of concrete example, let's try to understand how to write a state diagram. For example, the initial state of a user. So I am taking a use case of an ATM machine where the initial state of the user is unverified user. So before you have entered your ATM pin, you are an unverified. Whether you are a valid user or not, it's not known to the system. So once you enter the valid user ID and password, right, then it verifies it. Then it is waiting for the pin. So initial state is till you enter the pin, it is waiting. From that, now once you enter, it is validating that pin. Okay, yes, it is a valid user. Then it goes to the next state and then it says it's a verified user. Pin verified means the user has now converted from invalid user into the valid user. And then the final state is verified user, right? So there was an unverified user. Until he was entering the pin, it was in the waiting period, and once he entered it, if that pin was correct, then he became valid user. So he transited from unverified user to verified user. What if the pin is wrong, right? Then he again goes to the waiting period. Means ATM asks again one more time for the pin. It could do that for 3 times or 4 times. This is how we represent the state diagram. Thank you and for listening this state diagram video. In the next video, we will talk about remaining two types of UML diagrams. Those are deployment diagrams. We will also talk about sequence diagrams and so on. Thank you very much for listening to this video series.